All right, here's a couple of good questions. The first is a radical question, and the second is a rational one. So here they ask you to solve. One of the radicals is already isolated, so I can just square things. So I'll take root 3x plus 1, equals 3 plus root x minus 4, and I'll square both sides. Okay, so on this one, the square and the square root cancel, so it'll be 3x plus 1. And then on this side, I always like to write 2 of these if it's squared. Okay, now let's FOIL this. So 3 times 3 is 9. 3 times root x minus 4 will be a positive 3 root x minus 4. This times this is another positive 3 root x minus 4. And then finally, when you multiply a radical by itself, the radical cancels. So this will just be plus x minus 4. And this is equal to 3x plus 1. Okay, let's bring everything over on the left-hand side that's not a radical. So I have 3x plus 1 minus 9 minus x and plus 4 equals, now these two, when you add them together, will be 6 root x minus 4. Okay, now 3x minus x will be 2x. 1 minus 9 is negative 8, plus 4 is be a negative 4. Okay, equals 6 root x minus 4. It'd be real nice now at this point to divide both sides by 6, but these numbers aren't divisible by 6. You could divide everything by 2, but at this point it's probably easier just to square both sides again, to get rid of that square root on this side. So I'm going to take this side and square it, this side and square it. On the left, let's write 2 of them. So it'll be 4x squared minus 8x minus another 8x plus 16 equals, on this side I have to square the 6, so that'll be 36. And when I square the root x minus 4, the root cancels. It's still a group though, so I'm going to put it in a bracket, x minus 4. Okay, getting closer. Let's simplify a little bit on the left side. And then distribute that, so it'll be 36x minus 144, I think. Now let's bring it, because there's a quadratic involved, let's bring everything over onto the left. So minus 16x minus 36x plus 16 plus 144 equals 0. So 4x squared minus 52x, is that 160? Plus 160 equals 0. Okay, I'm hoping I haven't done anything wrong yet. I think I can divide everything by 4 though. Divide 4. So this would be x squared minus 13x plus 40 equals 0. Things that multiply to 40 and add to 13, 8 and 5. So x minus 8, x minus 5 equals 0. So either x minus 8 equals 0, in other words, x equals 8, or x is equal to 5. Now I'm feeling pretty good with those answers. Let's remember them, 8 and 5. But let's go up to the top and just see if they will check. So I was doing 8 and 5. And you probably should put this in a different check. I'm just going to do it quick though. So I put an 8 there. So it'll be 24 plus 1 is 25. Square root of 25 is 5. If I put an 8 here, 8 take away 4 is 4. Square root of 4 is 2. 3 plus 2 is 5. Yeah, so 8 checks out. Let's try 5. Okay, so if I put a 5 in for x, 3 times 5 is 15, plus 1 is 16. Square root of 16 is 4, I get on the left side. Okay, and I'm putting a 5 here. 5 take away 4 is 1. Square root of 1 is 1. 3 plus 1 is 4. Oh, so they both work. Okay, so both those answers will check out. All right, now let's take a look at this one. This question says I've got this equation and I want to solve it for T2. One of the problems I see is T2's on the bottom, and that's not a good spot if you want to solve for something. So what you can do is, to get it on top, you can multiply every term by a lowest common denominator. So for this one, the lowest common denominator will be Q T1 T2. So let's write our expression. So I have 1 over Q, and I'm going to multiply that by Q T1 T2, and you can say that's over 1, okay, is equal to 1 over T1, okay, and we're multiplying that by Q T1 T2 over 1, okay, plus 1 over T2, and again I'm multiplying that by Q T1 T2 over 1. So in the first one, it looks like the Q's cancel, so I'm just left with T1 T2. Notice no fraction is equal to T1 cancels, so this will be Q T2 plus T2 cancels, so this one will be Q T1. Whew, there. Now I've got my T2 on the top, but I've got a problem in that there's two T2s. But we've done that before to solve. If I want to solve for T2 and there's two of them, I want to get them on the same side of the equal sign and then factor out. So I'll have T1 T2. I'll subtract Q T2 on this side and subtract Q T2 on this side. So this will be minus Q T2 is equal to Q and T1. So on this side I have two T2s. I can get one just by factoring it out. So if I factor a T2 out, I'm left with T1 minus Q is equal to Q T1. Now there's just one T2. So to solve for it, this is multiply. So to get rid of it, I'll divide each side by T1 minus Q. T1 minus Q. So T2 then, these cancel, are equal to Q T1 over T1 minus Q. Do they have that answer? QT1, yeah. Oh, no, wrong. This one, that one right there. Right, hopefully that helps you out with those two questions.